Sorry about that. Welcome to switch statements. So in this chapter, or in this part of the chapter, we're going to talk about switch statements and how they affect our programs as control structures. So let's jump right in. So switch statements are the alternative to... sorry about that. Let me actually... That is a lot louder than I want it to be. All right. So switch statements are the alternative to if statements, meaning that they do somewhat of the same code responsibility that if statements do. They're a control structure. Occasionally, an algorithm will contain a series of decisions in which a variable or expression is tested separately for each of the constant and real values it may assume. So let's go ahead and write a switch statement. Before we go any further, let's go ahead and write one, shall we? All right, so let me do that and that. Alrighty then, we're in there. Okay, so let's put a switch statement inside this for loop, okay? So we have a for loop, and I'm going to write a switch statement instead of an if statement. So in this case, I'll say switch array I. Now what am I doing? I'm switching on the array I. Now that's very important, because I'm not putting a Boolean expression here. I'm not saying, hey, I want to see if something is less than or equal to something else. I am basically just saying, give me the value of whatever is in the I number. The I is the index number, array. Okay, the array of the index position I. So now, I'm going to write my cases. So I'm going to erase this. And I'll write as follows. Case, if I is 1000, or if the switch variable array I equals 1000, then what I want, actually I actually want that. Then what I want you to do is I want you to printf the array position value is 1000. Cool. And then break. Case 100. All right. And lastly, and we have to break here. Lastly, case 10, printf and then I'm going to breakpoint all this so we can see what's actually happening. Now, before we go any further, let's find out something really quick. What is happening? Well, let's talk about it. So first, the for loop goes out and gets the I position, checks to see if I is less than 10, and then increments it after the iteration. What's going to happen is it's going to go into this switch. Then we load array indexed by I. Okay, so basically what's going to load the first time we go through, array indexed at the 0th position. What's at the 0th position of this array? 1000. So if case equals 1000, the number, I didn't put quotations around this, so it's a number, not a string. If I put quotations around this, it turns it into string 1000. I don't want string 1000 because that's not what's in the array. What's in the array are integers. So I said, switch on this, case 1000, print this. If array I equals 1000. If the array I equals 100, do this. If array I equals 10, do this. All right, let's break point for a second here, and let's see what's actually happening, shall we? I don't want that, and I want that. Okay, so let's run it. All right, so we got our first break. Now, obviously, the array loaded, and we have all of our values, 1000, 110, and all the other variables that are in there that are the value locations, okay? And then the for loop starts. So I right now equals 0. I, which is 0, is less than 10. It's going to increment by 1 when the iteration's over. Now, we're going to look at the switch. Array I equals what? 1000, because I is 0. So array at the 0th position is 1000. So what's going to happen? Well, if this is true, okay, if this case is true, it should print the array position value is 1000. So let's see what happens next. It went into that case. So now it's going to print the array position is 1000 and then break. Now what's break for? Break tells the switch loop or the switch control structure to stop looking at any other cases. This is the case that was true, therefore break and leave the switch statement. So that's what should happen. Let me see, what did we get? Oh, it iterated through all 3 times. And as you saw, it skipped the 1000, the 100, and the 10. As a matter of fact, let me put this out of order. Okay. So you can see the skips. Because that looked like it just went through one time. Stop. There we go. Save, and let's run that again. So the first iteration is going to hit 1000, as it should. And if I open this up and then hit continue, you'll see that it printed the array position values 1000. That means that the case 1000 ran. Now if we look at where this loop is. It skipped 1000 and skipped 10. Why? Because array at index I of I is 1, because I is 1 right now. So I is 1. This is the second iteration. That means that 100 is the value. Therefore, case 100 should be true. Case 10 is not true. Case 1000 is not true. So what's going to happen? The array position is 100. That's what's going to print. Now the loop went again, and we have it at case 10. And you can see case 100 printed, and now case 10 is going to print, and all is well in the world. So let's go over the text and see what the text has to say about this. So, a switch statement is called a multiple selection. C provides the switch multiple selection statement to handle such decision making. The switch statement consists of a series of case labels and optional default case and statements to execute for each case. Uses switch or 4.7 uses switches to count or switch to count the number of each different letter grade students earned on an exam. So, unsigned int A count, B count. I use an array because I just think it's better to do that. And then prints off what we want. So into the letter grades, enter the EOF character to end the input, and then int grid. And here we go. While grade is equal to nothing, so get char. Wait, this is confusing. Loop until user types end of file key sequence. Okay, so once the user says we're at the end of the file, stop. And here we go. It asks for both cases, uppercase and lowercase a, and then it says increment the variable a count by 1 and does so for the b count and c count as well as the d count. And then it makes new lines, and then it caches all the characters, and then it prints everything out. And it looks something like this. It also had an exception catch that said if you did not add a character that you needed to enter a letter grade. So, while grade equals char is it reading the character input. So, while in the while header, the parenthesized statement grade equals char executes first. The get char function reads one character from the keyboard and returns it as an int. The character that the user entered. Characters are normally stored in variables of type char, not string, char. However, an important feature of C is that characters can be stored in any integer data type because they're usually represented by 1 byte integers in the computer, meaning you can store anything in int, kind of. Thus, we can treat a character as either an integer or a character depending on its use. For example, the statement the character, and this is a char, has the value and this is an integer, uses the conversion specifiers C and D to print the character A and its integer value respectively. Therefore, the character A has the value of 97. 97 is its ASCII value. It's a numerical representation that the computer understands it to be. So if you said, I want to know the integer value of A, it will give you the ASCII2 integer value, which is 97. And there you go. Many computers today use the ASCII2 character set in which the 97 presents the lowercase letter A. And there you go. The value of the assignment expression grade equals get char is the character that returned by get char and assigned to the variable grade. The fact that assignments have values can be useful for setting several variables to the same value. For example, A equals B equals C equals 0, meaning that everything equals 0. That's what that means. We use end of file, which normally has the value of -1. -1 means the end of in most situations. So if you said you want the array position -1, you're going to get the end of the array. So if I said in this right here, and I will comment this out because this switch might be useful later. if I said I want, I actually don't care about this for loop at the moment either, so I'm going to comment that out. Let's say I said I want array, puts array I. I'm sorry, -1. What I should get here is 10, because 10 is the last element in the array. All right, you know what? You're not playing nice. What did I do wrong? An axis. This is very annoying. It's very annoying when this happens. All right. There. All right, now it should work, please. The last position in the array is technically that is the last position in the array, to be honest. But it gave me the last position. That is not accurate, but I'm gonna go with it. So basically, it's gonna give me the last. It gives me the last character in any value. So, oh, I can try something else actually. Let's try this. Let's say int value equals 1000. All right, and we'll just say value. Okay, let's run it. The last position. Oh, that's not cool. I wanted to get. All right, fine. There we go. Settle. So the last position in the array, this is not an array, it's an integer, but all I wanted was the last digit, the last character in this, or the last digit in this number, which was 0, and that's what I got by using the last position, 0, 7, 7. Oh, I didn't say fiddlesticks. I did that wrong, didn't I? All right, nix what I said. Try this one more time. Let's say local little Edels. Well, I guess it's not going to work. But I should have gotten the last character in this digits in this number, but c'est la vie. All right, I did not mean to do that. Testing for the symbolic constant EOF makes programs more portable. The C standard states that EOF is a negative integral value, but not necessarily -1. You saw when I put -1 in the array, I got -8,000, 800,000, 8 million, whatever. Yeah. Sometimes EOF is more specific than -1, but in most languages other than C and Objective-C, -1 means the last thing in the array, or in the char, or in the string, or in the number, or whatever. So, on Linux, Unix, Mac OS X systems, the EOF indicator is entered by typing Control-D. On a line by itself. This notation Control-D means to press the enter key, then simultaneously press both Control and D. On other systems such as Windows, Control-Z is how we make the EOF indicator. The user enters grades at the keyboard, and then when they're done, they enter Control-Z. So, keyword switch is followed by the variable name grade in parentheses. This is called a controlling expression. So if I open up Visual Studio after I closed it, by accident. Okay. And I say, may I have that back, please? And then I said, I don't want you anymore. And I want you back. Okay. Oh, love it. All right, here we go. So, if we look here, it says, this is called controlling expression. So this array I here is the controlling expression, is what the switch statement is basing its decisions off of. The value of this expression is compared with each of the case labels. Assume the user has entered the letter C as a grade. We've gone over this already in the code. Just understand that what the case statement does is it goes one by one through the cases to see which one is right. And when it does get to that case, it breaks. So let's keep going. Yep. If break is not used anywhere in the switch statement, then each time the match occurs in the statements for all the remaining cases will be executed called fall through. We don't want that. You want the case statement to be specific. You want it to stop at a specific place. And once it gets the match that it's looking for, it needs to stop. So put breaks in all of your cases. And this is what a control chart or flow chart looks like for a switch statement. Case A true, break. Case B true, break. Case Z true, break. Otherwise default actions. A little different than from the if statements. So, the ignoring the new line and blank characters and input, basically you can tell it, hey, ignore these things and don't pay attention to them because they're not important. It's not necessary in most languages. C, it probably is. Just remember you can do this. This is for ignoring new lines, this is for tabs, and this is for spaces and input. And then what you can say is break the switch, and then it exits the switch altogether. So. Listing several case labels together, such as case D, simply means that the same set of actions is to occur for either of these cases. So if you have one case after another, as you saw in the code that we saw here in the PowerPoint, then what it'll do is once it gets case D, uppercase, case D, lowercase, and then if you have the values of what you want to happen after that last one, everything preceding that case will fire as long as there was no break. So case D and case D have no breaks in them, so they're going to go one after the other. It's called fall through. When using the switch statement, remember that each individual case can test only a constant integral expression, any combination of character constants and integer constants that evaluates to a constant integer value. A character constant can be represented as the specific character in single quotes such as A, and characters must be enclosed within single quotes to be recognized as a character constant. Character constants are also known as strings. Integer constants do not have quotes, and they are known as integers. We've used them a lot as well. So, portable languages like C must have flexible data type sizes, meaning that you have to pay close attention to the size of the data type that you are using at that moment. For short ints and ints in general is between 32,000 and 32,000 plus or minus. Long ints also have a bigger range. This is, I think, 2 trillion or billion or something along those lines, or 200 billion, 2 trillion. And then you have signed chars that can be between 127 and 127, but that's based upon the fact that chars are represented by the ASCII 2 characters, and there's only a certain amount of keys on your keyboard, are there not? Each one of them has a specific ASCII 2 representation. So, that is all for this video. In the next video, we will go over do-whiles. I hope this was a very intuitive, very easy to understand video, and I hope it gives you the tools you need to succeed. Otherwise, I bid you adieu. Ciao.